Hello all, welcome to the new video of Signals and Systems video channel. In this video we'll see how to determine whether the linear combination of signals is periodic or aperiodic signal. So when I say linear combination of signal, I mean this. Suppose we have two signals x1 of t and x2 of t. So both are continuous time signals, hence both are periodic signals. So the combination of these two, whenever I say combination, I mean linear combination of these two signals. Let's say the linear combination of these two signals be g of t, then g of t can be represented by a x1 of t plus b x2 of t. So in our case, both x1 of t and x2 of t are periodic signals. However, when we add these two signals, we need to find out whether the linear combination of these two signals is periodic or aperiodic. It may not always be periodic signal. So aperiodic. So let's see with an example how to find out whether this linear combination of these two signals x1 of t and x2 of t is periodic or aperiodic signal. If it is periodic signal, we'll find out the period of this g of t. So let's see, I will give you a trick how to find out whether this g of t is periodic or aperiodic signal. So let me summarize what we have learned till now. We have linear combination of two signals x1 of t and x2 of t. So both x1 of t and x2 of t are periodic signals as they are continuous time signals. All continuous time signals are periodic in nature. However, the linear combination of those two continuous time or periodic signals may be periodic or aperiodic. So our job is to determine that. So let's see how to find out whether the linear combination of these two signals is periodic or aperiodic. Say to begin with, let's say the fundamental period of x1 of t be t1. This is fundamental period of x1 of t. In the same way, fundamental period of x2 of t be t2. So here is the definition. G of t is periodic signal, that is linear combination of x1 of t and x2 of t, that is g of t is periodic signal if t1 upon t2 is a rational number. So this is the trick. Okay, the g of t is periodic signal if the ratio of time period of fundamental period of x1 of t upon fundamental period of x2 of t is a rational number, and if g of t is periodic signal, it will be having a fundamental period of its own. So that fundamental period, let's see how to calculate that. What is fundamental period of g of t? Our next question is, what is fundamental period of g of t? Okay, I will take a new page. So g of t is periodic if t1 upon t2 is a rational number. Since g of t is a periodic signal, it will be having a fundamental period of its own. So to calculate fundamental period of g of t, fundamental period of g of t, what is this? So the fundamental period of g of t is equal to nt1, which is same as mt2. That is, this n goes here, just cross multiply. nt1 is equal to mt2. So this is the fundamental period, provided the GCD of m and n is equal to 1. So then only if GCD of m and n is 1, then only we can use this formula. The fundamental time period then becomes nt1, which is same as m times t2. So this is how you calculate whether the linear combination of two signals is periodic or aperiodic. If it is periodic, then you can calculate the fundamental period in this manner. Okay, so I'll quickly take an example to illustrate what we have learned till now. I'll give you two examples where we can check. Okay, so let's see an example. Here, let g1 of t be a linear combination of 3 sin 4 pi t plus 7 cos 3 pi t. Our job is to check whether g1 of t is periodic or aperiodic signal. So if it is periodic, then we have to determine the fundamental period. So let's follow the procedure. Let's first find out what is t1. Since omega 1 is equal to 4 pi, so this will become 2 pi upon t1 equal to 4 pi. So t1 is equal to 1 by 2. And the same way omega 2 is 3 pi. So t2 will become 2 by 3. So let's see what is t1 upon t2. This will become 1 by 2 upon 2 by 3. So it will be 3 by 4. Let us call this ratio as m by n. So what we have learned, a g of t is periodic signal if t1 by t2 is a rational number. Since 3 by 4 is a rational number, this whole t1 by t2 is a rational number. So g1 of t is a periodic signal. So since it is a periodic signal, it will be having a fundamental period. So that fundamental period can be calculated this way. Since this nt1 and mt2, these are two are there, so the fundamental period will be n times t1. That will be, since n is 4, t1 is 1 by 2. This will be 4 into 1 by 2. This is 2 seconds, which is same as m times t2. What is m? M is 3 and t2 is 2 by 3. This is 2 seconds. So this is the fundamental period, provided GCD of m and n is equal to 1. Here what is GCD of m and n? This is 1. So I'll summarize. First what we did, we calculated the time period of these two independent signals, sin 4 pi t and cos 3 pi t. We got t1 is equal to 1 by 2 and t2 is equal to 2 by 3. By definition, g1 of t is periodic if the ratio of t1 upon t2 is a rational number. Here the ratio of t1 upon t2 is 1 upon 2 and 2 upon 3. This is 3 by 4, which is a rational number. So since g1 of t is a periodic signal, it should have a fundamental time period. So it can be calculated by either n times t1 or m times t2, provided GCD of m and n is equal to 1. In our case, m is equal to 3, you can see here, and n is equal to 4. So GCD of 3 and 4 is 1. So the fundamental period can be calculated by n times t1 or m times t2, which is 2 seconds. So it is a periodic signal, and fundamental period is 2 seconds. So let's see another example. So let's see a second example. G2 of t, which is 3 sin 4 pi t plus 7 cos 10 t. Let's check whether this is a periodic or aperiodic signals. So omega 1 is equal to 4 pi, which is 2 pi upon t1 equal to 4 pi. t1 is 1 by 2. In the same way, omega 2 is 10. This is 2 pi upon t2 is equal to 10. t2 is pi upon pi. So G2 of t is periodic if t1 upon t2 is a rational number. So what is t1 upon t2? This is 1 over 2 upon pi over pi. This will become 1 upon 2 into 5 by pi. This is pi upon 2 pi. So this is not a rational number. So G2 of t is not a periodic signal. So even though both were periodic signals, the combination of these two is a periodic signal. It is not a periodic signal. Okay. So you can also see in the diagram here. This is the first which we had solved, G1 of t, which is 3 sin 4 pi t plus 7 cos 3 pi t. It is periodic with fundamental period 2 seconds. And for G2 of t, it is not a periodic signal. You can see here the peak starts at here, however it will not end here. However, in the first case it is a periodic signal. So that's how you determine whether the linear combination of signals is periodic or aperiodic signal. So thanks for watching. If you have any doubts, please use the comment section, and please don't forget to subscribe our channel. Thank you.